Hello everyone, welcome back to another video from Winter Forest. If you enjoyed this, please like and subscribe for similar videos. And today I'm going to continue a math coding challenge. And today's question is cousins in binary tree. So let's look up the question. In a binary tree, the root node is at depth 0 and the children of each depth k nodes are at the depth k plus 1. Two nodes of a binary tree are cousins if they have the same depth, but have different parents, so they expect not simply. We are given the root of a binary tree with a unique value, and the value x and y of two different nodes in the tree return true if only if the node corresponding to the x and y are cousins. Let's look at example 1. They give you give you the binary tree 1, 2, 3, 4, and they give you 4 and 3, and you return the false because they are why? Because the depth is different. This is 0, 1, 2, and this is 1. And in here, they give you a binary tree, and you give you 5 and 4. This is true, because we need to return true. They are both need not assembly. Second thing, and they have the same height, 0, 1, 2, 0, 1, 2 here. And so the same level. And then this one, let's look at the binary tree, then give you 2 and 3. But 2 and 3 is a symbol, so it is false. The number of the nodes in the tree will be between 2 and 100. Each node has a unique integer value from 1 to 2. This is what they're giving. So actually, just basically you need a loop the tree we're going to check. When I'm coming in, I just check the given nodes. They are the binary symboling or not. If they are not symboling, we just find the invalid case. If they're symboling, then return false. And also we need another invalid case. If the height is different, you see, the height different also return false. This is false. And this is false. Simply return false. Height different and return false. Otherwise, they're not simply, then we only need to check if the height is the same. Then we will return true. So what we going to loop, we need to binary tree. Normally you do recursive loop because they are the tree. Just once you get a root, then you move to this one, you treat this like a root. Then you can continue going. So just let's write the code. Then we could go through with this example. So what I'm going to do, so we're going to have, like I said, I'm going to find the height x and going to do a recursive loop. So you could provide the root nodes and the x, and the 0 will be a level. So once you go deep one level, then you plus 1 until you find the x. So we need a help method for this one. So this will return integer. I'm going to find my x level, trees this node's level, and this is the root, and then the index, and then is the level. So I accept 3, and we implement this later. So in the x, also x is this one, and in the y is the same. So you find that if they are And okay, so if they are not the same height, but we also need a test if they are sibling or not. So we actually also need a valid helper method. And is sibling or not is the return true or false boolean. Yes. So going to accept the 3 nodes. Each time I said, each time you come in, you compare, treat this like a root. Compare the passed in node, there is the left or is the right. Yeah. So you have the nodes passed in, they are integer. You're trying to find they are the sibling or not. If they are the sibling, that means they are the same, have the same root nodes, and the left or right, or just right or left. Okay. So actually, is sibling check is much simple. So how you know it is sibling or not? So you go into continue looping. So first you check if the finish, the base point is this one. If root equal to null, means you already at the end, then you just return false. Otherwise, you just return compare. What kind of position? It is root dot left not equal to null, and root dot left dot value will be equal to x, and root dot right not equal to null, and root dot right dot value will be equal to y. This one, but you also could be another similar. It is the swap position or didn't copy. Or if left equal to y and right equal to x, then they are definitely simply they have the same parent. And also have a if this one in this first row didn't find it, how about you continue looking the child, then you recursive looping it. Oh. So this is, I think this is obvious. So you first see if they have the root, this is the root nodes, this is the root nodes. Then you see if left right equal, and left and equal to x, right equal to y, or you swap it, left equal to y, right equal to x. If this is not the root nodes, you didn't return false, then you continue going to call this sibling, and you pass the root dot left, continue looping, and the sibling root dot right until you find it, until this find any one of the, then you return the value to here. So you go into here, you're going to see if, so this have two conditions will be fair. If is sibling, then definitely going to fail. Or the high not equal to, both not in the same high, they're not a sibling, but they're not the same high, you return false. Else, if, and this definitely return false, if they are, else if they are not a sibling, and we compare if they are equal. This is the only valid case you could have found it. Then you say true. Then the rest of return false. Yeah. So at the moment left to find the high. Find the high, we also going to do recursive loop. We treat each node like x and y, x and as a root. Keep looping until you find the x, otherwise you just add the level. The level starts with 0 position, then you're going to find until the root equal to null. If root equal to null, then you directly return 0. And if not, you see if the root value already equal to x, then you return level. Actually, it is the root level, so also is 0. And otherwise, just return. Find this in the left or in the right. So you get the max. You're going to find this in the left or right. Just you keep looping. So you're going to find this one. Going to the left. You go deeper one level, so you plus 1. If you're in here didn't find it, you're also looping the right. You don't know they're in the x level or in the y level. So you're going to in the left level or in the right level. So you go left and the right, loop together to find the maximum. Yeah. Let's run it, see if could satisfy. Hope I don't have a syntax issue. Combine issue. Return label 35 in here. Label. Yeah. To find which label there, LEL, missing L, run the game. Is symboling. Okay. Is symbolings. Is symbolings. Is symbolings. Is symbolings. Okay. Okay, it's finished. Just go through it, then submit it, and make sure I don't have it. So we're going to check. I use a helper function, find if both the nodes are high, and if they are not is symboling, or they are not the same high, they directly return false. Otherwise, could be only otherwise there won't be parent. Then could be coming out from here. Then we check they are the same high, then return true. Otherwise, if cannot find it, then directly return false. How to find the high is in here. So if the root node return 0, either the current level value equal to this level, just return this level. Because the second time coming, you could be already found it, then you will be returning here. So you keep looping the finding nodes, going to left, and once you go down level plus 1, right, go into level plus 1, yes, find the, yeah. Then you compare this is simply, yes, let's submit it. Yes, it accepted. Thank you for watching. Hope this helped you.